So in this video, we are going to start a new chapter in physics, that is chapter number 6, work, energy and power. So firstly, we understand and we discuss about different aspects of work. What is the definition of work? So we talk about the definition of work. So work is said to be done. Work is said to be done when we applied a force on a body and there is displacement experienced by a body in a direction of applied force. Means for work done, two things is necessary or two conditions must be satisfied for work done. The first is force must be applied, and the second condition, the displacement should be in the direction of the applied force. So the definition of work is said to be done. Work is said to be done when we apply a force, when we applied a force on a body and there is displacement. When we applied a force on a body and there is displacement experienced by the body, and there is displacement experienced by the body or by a body in the direction of applied force, and there is a displacement experienced by a body in a direction of applied force. This is the definition of work done. Work is said to be done when we applied a force on a body and there is displacement experienced by a body in a direction of applied force. So work is done by a body or work is done on a body only if two conditions are satisfied. Work is done on a body if two conditions are satisfied. If two conditions are satisfied, work is done on a body if two conditions are satisfied. First, a force acts on the body. The first condition is a force acts on the body. And the second condition is the displacement should be in the direction of applied force. The displacement should be in the direction of applied force. Applied force. So to perform a work or work is done on a body if two conditions are satisfied. The first condition is a force must act on the body, and the second condition is when the force acts, then the displacement must be in the direction of applied force. Examples of work done. The first example is work is done when a horse pulls a cart. Work is done when a horse pulls a cart. When a horse pulls a cart, the work is done because the horse applied the force in forward direction and the displacement experienced by the cart also in the forward direction. So work is done when a horse pulls a cart. Second example, work is done when an engine pulls a train. Because engine applied the force in forward direction and the displacement also experienced in the direction of applied force. So we have seen the definition of work. Work is said to be done when we apply a force on a body and there should be displacement experienced by the body in a direction of applied force. And to perform the work, and work is done on a body if two conditions are satisfied. The first condition is the force must be acts on the body. A force must act on the body. And the second condition, the displacement should be in the direction of applied force. And examples of work done is work is done when a horse pulls a cart. Work is done when an engine pulls a train. Now we talk about work done by constant force. The next topic which we discuss, work done by a constant force. Work done by a constant force. The force acts on the body is constant. The measurement of work done when the force acts along the direction of motion. Measurement of work done when the force acts along the direction of motion. The constant force acts along the direction of motion. So suppose there is a horizontal surface and there is a block. And when we apply a force on this block, the block experiences a displacement S in the forward direction. This is the initial position of the block, and when we applied a force F in the forward direction, when we applied a force on this block in the forward direction, there is displacement experienced by the block in the same direction, in the direction of the applied force. Body displaces from one point to another and it covers a distance s, and the applied force F is a constant force. Then work done is given by W equals to F dot S. When a constant force F applied on a body and there is displacement S experienced by a body in the direction of applied force. When we apply the force on a body and there is displacement experienced by a body in the direction of applied force, then work done W is given by F into S, F dot S. So this is the work done by the constant force and measurement of work done in the direction of applied force. Now the next is measurement of work done when force and displacement are inclined to each other. Measurement of work done. Measurement of work done when force and displacement, when force and displacement measurement of work done when force and displacement are inclined to each other. Are inclined to each other. This is the second case when the force and displacement are inclined to each other. So there is a horizontal surface and a mass and a body is situated at a certain point, and the force applied is F. Force applied on the body is F, and this is the component of the force in the direction of applied force. And after applying the force, body changes its position and the body covers a distance of a displacement of S, and force is inclined at an angle of theta with the direction of displacement. Force is inclined at an angle theta with the direction of applied force. So there must be the displacement is in the horizontal direction. Body reaches from one point to another in horizontal direction. So the displacement in horizontal direction. So the component of force will be taken as the horizontal component of the force. So the horizontal component of force is given by F cos theta and displacement is S. So when the force and displacement are inclined at an angle theta to each other, then in this case work done W equals to the horizontal component of force would be taken. So W equals to F cos theta into S. Work done equals to F cos theta into S, which is also written as W equals to F S cos theta. And this is the dot product. Fs cos theta is written as F dot S. So W equals to F dot S. Because F dot S is written as Fs cos theta, where theta is the angle between force and displacement. Here theta is the angle between force and displacement. Thus we conclude that work is the scalar product. Work is the scalar product of two vectors. Work is the scalar product of two vectors. Force vector and displacement vector. Force vector and displacement vector. Work is the scalar product of two vectors. Force vector and displacement vector. Hence work is a scalar quantity. Since work is the dot product of force and displacement vector, since work is the dot product of two vectors, force and displacement, hence work is a scalar quantity. Because when two vectors are multiplied by dot, the result always comes to be a scalar quantity. So force vector and displacement vector are multiplied by dot, and these two are the vector quantities. So the result will come the scalar quantity. That's why work is a scalar quantity. Now we discuss nature of work done in different situations. Nature of work done. Nature of work done in different situations. Nature of work done means positive work done, negative work done, or zero work done. So first we talk about the positive work done. Positive work done. Nature of the work done means there are three types of nature. Either if the work done is positive, negative, or zero. So if the force acting on a body, if the force acting on a body If the force acting on a body has a component, if the force acting on a body has a component in the direction of displacement, if the force acting on a body has a component in the direction of displacement, if the force acting on a body has a component in the direction of displacement, then the work done is said to be positive work done. Then the work done is said to be positive work done. So this is the definition of positive work done. If the force acting on a body, if the force acting on a body has a component in the direction of the displacement, then the work done by the force is positive. Work done by the force is positive. Suppose there is a body and the force F acts on the body, and the displacement by the body is in horizontal direction, and the component of the force here is F cos theta. So the component of the force and the displacement are in the same direction. The component of the force F and the displacement both are in same direction. So in this case, work done will be positive, because when the component of the force and the displacement be in the same direction, then theta must be acute. When the component of force and displacement when the component of the force and displacement be in the same direction, then theta must be acute. Means the value of theta must be less than 90 degree, and any value less than 90 degree cos theta, and the theta is less than 90 degree, then it will be positive. So for positive work done, the angle theta should be acute. And when the angle theta will acute, when the component of force and displacement acts in the same direction, then theta must be acute. And when the theta be acute, then work done will be positive. When theta will be acute, then the work done will be positive. Now we discuss about the examples of positive work done. Examples of positive work done. The first example is when a body falls freely under the gravity. When a body falls freely under the gravity, when a body falls freely under the gravity, then theta equals to 0. When a body falls freely under the gravity, then theta in this case is 0, because when a body falls under the effect of gravity, the direction of displacement is in downward direction, and acceleration due to gravity also acts in the same direction, vertically downward. Displacement and acceleration due to gravity both are in the same direction, and they are in the same direction. Acceleration due to gravity and displacement, it means theta equals to 0. And if theta equals to 0, then the work done will be positive, because W equals to Fs cos theta. And if theta is 0 degree, then we know cos 0 is positive 1. So work done equals to Fs, positive work done. So when a body falls freely under the gravity, then theta equals to 0 and work done is positive. Work is positive. Because why work done is positive? Because the direction of acceleration due to gravity and the displacement is same. So work done by the gravity is positive. We conclude that work done by the gravity, work done by the gravity is positive. Work done by the gravity is positive. When a body falls freely under the gravity, then work done by the gravity is 0, because theta is 0. The applied force, the direction of force and the displacement is in the same direction. Therefore, the work done is 0. Now we talk about another example of positive work done. This was the first example of positive work done when a body falls freely under the effect of gravity. The second example, when a horse pulls a cart. Second example, when a horse pulls a cart, then the direction of displacement, then the angle between force and displacement. When a horse pulls a cart, then the angle between force and displacement is 0 degree. When a horse pulls a cart, then the applied force and displacement are in the same direction. Then the applied force and displacement are in the same direction. Then the applied force and displacement are in the same direction. And if the applied force and displacement are in the same direction, then theta is acute. The angle between force and displacement is acute, and if the angle between force and displacement is acute, they are acting in the same direction. So work done by the horse is positive. Work done by the horse is positive, because the applied force and displacement are in the same direction. The applied force and displacement are in the same direction. Therefore, work done by the horse is positive. So this is the second example of positive work done. The first example of positive work done was when a body falls freely under the gravity. When a body falls freely under the gravity, then the angle between force and displacement is zero. Therefore, work done is positive. And second example is when a horse pulls a cart, then the applied force and displacement are in the same direction, means theta is acute, and work done by the horse is positive. We continue this topic in the next video.